Hi everyone. Today we are going to discuss about Carbanion structure and different types. Yeah, let's start. What is Carbanion? The carbon carrying negative charge. Negatively charged carbon species is called Carbanion. Right. Here in this Carbanion, the carbon is bonded with 3 hydrogen atoms or 3 alkyl groups and carrying one lone pair of electrons. Right. That's why here the number of covalent bonds around the carbon is 3. So that's why number of bond pairs of electrons 3 to 6 and one lone pair is present. So totally there is 8 electrons are present. But that lone pair is in the non-bonding state. So that's why the carbon undergoes sp2 hybridization. Right. And 8 electrons are present. So 8 electrons are there, but one is a lone pair of electrons. That's why all are paired electrons. There is no unpaired electron. That's why it is a diamagnetic in nature. Right. And then you can represent structurally here. What is there is the carbon carrying negative charge. The carbon having negative charge is called carbanion. Right. And you can take the simplest carbanion CH3 minus. Okay. So here the carbon is bonding with 3 hydrogens, or you may take alkyl groups also. There is here, you can represent for our convenience. This is R1, R2, R3. It is R1, it is R2, it is R3, and it having one lone pair of electrons. So this is, you can represent, there is according to stereoisomerism. So it is away from the observer, right? And this is toward the observer. Okay, yeah, right. Now here carrying one lone pair of electrons. One lone pair of electrons are present. Okay, right. Now, so in this case, it having totally the total number of covalent bonds. The total number of covalent bonds that are surrounded by carbon is 3 covalent bonds. That's why total number of electrons present on the valence shell of carbon, there is 3 into 6 electrons, 3 covalent bonds, and one lone pair is present with 2 electrons. Total 8 electrons are present. So these 2 electrons are lone pair of electrons. They are not present in the bonding state. Okay. So that's why here these are there 8 electrons totally, and then this electron rich species, because it can donate this lone pair of electron to others. That's why it is a electron rich. This electron rich, it can donate this lone pair of electrons. It is a electron pair donor. This electron pair donor, according to Lewis scientists, electron pair donors are considered as Lewis bases. So that's why these carbanions are act as a Lewis bases. They are electron pair donors, right? And these are unstable or stable. Unstable. Why? Because 6 electrons are there in the bonding state, and this is a lone pair of electrons. So because of presence of lone pair, it is in the non-bonding state, right? So we have to donate that lone pair of electron to some others, and it can make a bond with that. Then it is going to stable. So that's why it is unstable. It is unstable. Okay. So because of there is no bonded state in the 4th covalent bond, right? Next one. So because it is unstable, to getting into stable, to reach stable state, we have to donate that lone pair of electron to some others. So that's why it is actually participating in chemical reaction to donate that lone pair of electron to some atom and make a bond with that and getting a product. So that's why it is highly reactive, actively participate in chemical reactions. It is highly reactive species, right? Okay, and it is a dia or para, because it is there is no unpaired electrons, all are paired. So that's why it is diamagnetic property. Diamagnetic, right? Because there is no unpaired electrons. No unpaired electrons. Okay, absence of unpaired electrons. You can say this is diamagnetic. Why is diamagnetic nature? Because there is no or absence of unpaired electrons. Right? Okay. Is it clear? Right now. Next one. Absence of unpaired electrons. Fine. Yeah. Next one. Here the carbon undergoes what type of hybridization? It is sp3. We can represent for our convenience like this. To take here, this is a lone pair is present here. Okay. We can represent for our convenience like this also, or maybe like this also. That is, we can represent. So here lone pair is present. So this is 1, 2, 3, and this is the lone pair is present. This is a R1. It is away from the observer, right? It is R2, and this is toward the observer, right? Okay. So here totally it is like this. For our convenience, we just represent this one. It is a ammonia, NH3 molecule is there, right? So that's why the carbon undergoes sp3 hybridization. Then you just flip it. On flipping, you will get like this. This group will come here this side. It is a lone pair of electrons, and this is R1, and this is R3, and this is R2, right? That means on flipping, you will get this one, this structure. That means it is optically active. It is a image. It is a image of this object. That means it is showing mirror images of each other, right? So it is on flipping. Okay, on flipping. So what you will get on flipping? Okay, on flipping, what you will get? Both are mirror images of each other. Mirror images of each. Okay. So because of their mirror images, it is optically active. It is optically active, right? Okay. So this one you can represent like this. This is a R1, R2, R3, and this is a lone pair is present. So this is what the geometry of the molecule is pyramidal. Okay. So sp3, but it is not tetrahedral because lone pair is present. This lone pair is present. It is like an ammonia molecule, In case of ammonia, so this is a lone pair. Here hydrogens are there. So here also nitrogen undergoes sp3. Like that, here also the carbon undergoes sp3, and it have pyramidal geometry. Okay, trigonal pyramidal geometry. Is it clear? Right? Okay. So this is the structural aspects, my dear students. Up to here you got it, all of you, right? Okay. It is a pyramidal, right? Okay. Yeah. Next one. Then types of carbanions. There are different types of carbanions are there, right? Saturated carbanion, unsaturated carbanion. Saturated carbanion, it is alkyl carbanions. Saturated carbanions, that is alkyl carbanions. That is methyl carbanion, ethyl carbanion, isopropyl carbanion, tertiary butyl carbanion, right? So for example, take it here, methyl carbanion. So there is CH3, okay, and here this is carrying negative charge. Here this carbon, this is a methyl carbanion. So this methyl carbanion, this carbon undergoes sp3 hybridization. This is sp3 hybridized carbon, right? Next one, second one is to get ethyl carbanion. Okay, there is ethyl carbanion represent, there is CH3, CH2 plus minus. Okay, CH3, CH2 minus. So this is ethyl carbanion, right? Then unsaturated carbanions. This is saturated. You can move now. Unsaturated carbanion. There is so here take it here 3 carbons or 2 carbons, and here double bond is there, and this is CH2 and CH, and here CH2 minus, right? Okay. So this is 3 carbons are there. It is a propenyl carbanion. Here propenyl carbanion. Alkene, right? This is propenyl carbanion. Here the carbon atom undergoes sp2 hybridization. sp2 carbon, not sp3. Why? Because here, so how many sigma bonds are there? This is 1 with 2 hydrogens, 2. Total 3 sigma bonds are there, and this is a this lone pair is present in the vacant pure p orbital. So that's why it is sp2 carbon. This is okay. Next, this is a propenyl. Next, another one is written here. This is 2 carbons are there, double bond, and it is carrying a negative charge. This is CH2, CH negative charge. So this is ethynyl carbanion. 2 carbons are there. There is alkene. ene, right, propene, okay, propenyl, and this is ethenyl carbanion. Here also the carbon undergoes here one sigma bond and here one sigma bond, so that is here this is a pi bond is present, okay, so that's why here also the carbon atom undergoes there is sp hybridization, right. Next one, take it here, propynyl carbanion, okay, so here one sigma bond is there right here, and here also one sigma bond is there right here, and this is a pi bond is there right here, so this is one pi bond is present right here, so that's why one sigma bond, another sigma bond, and this lone pair is present on the sp2 hybrid orbital, so that's why this undergoes, this carbon atom also undergoes sp2 hybridization. Take care here. So this is very important, my dear students. So one time they frame the question, in propenyl carbocation lone pair is present on the pure atomic orbital, p orbital, but here in ethenyl carbanion the lone pair is present on the sp2 hybrid orbital. Take care, right. And here this is a alkynyl, you take it here, there is a CH triple bond C minus. Here this is ethynyl ethynyl I, okay, I means ethyl, that is triple bond is present, right. This is a ethynyl carbanion. So here the carbon undergoes sp hybridization, sp hybridized carbon, right. Okay, next one is, this is a C6H5 CH2 minus, okay, so this is what, this is a benzyl carbanion, right. There is benzyl group, right, C6H5 CH2, so it is a benzyl carbanion. So in this benzyl carbanion, okay, the carbon is undergoes sp2 hybridization, right, sp2, right. Next one, it is a phenyl, so this is phenyl carbanion, right, it is a phenyl carbanion, okay, got it. So these are all the different types of that is carbanions, okay, is it clear, my dear students? Yeah. So next, this is the structural aspects and types of carbanions. The next part we are going to discuss about stability of different carbanions and which effects are influenced to stabilize it, and different examples I am giving to you. You just follow that one, okay. So thanks for watching my video, my dear students. If you like it, share it and subscribe it, okay, fine.